Let's have a look at question 31 in this video. So we have a friend who proposes to test whether the income is smaller than $16,000. So we have the hypothesis that the income might be less than $16,000. Now the p-value for these statistics is the following. Now why would we have such a test to begin with? Because we can see that the average of our sample of 49 observations have $15,000 as an average income, and that is less than what we used to think, because we used to think that it's 16,000. So we want to know whether this difference is significant, is large enough, or is it just by chance. So we want to know whether this difference is significant. Now, how can we calculate this difference? How can we calculate whether it is significant or not? Well, we want to know what is the probability that this difference happened by chance. And whenever we're dealing with probabilities, we have to have a signal in our mind that we're going to deal with the z-distribution, with the z-statistic. Now we have the relationship between the average sample, and we have the sample average and the population average. So the mu under our hypothesis is $16,000, but we might think that 15,000 is significantly different. So to standardize this, we want to see by how much does the sample average differ from the population average in terms of standard errors. So by how many standard errors does the sample mean differ from the population mean? Now what is the standard error? The standard error is the standard deviation of the population divided by the square root of n of our sample. So the standard deviation of the population is equal to 1,000 divided by square root of 49, because the number of observations is 49. So that's equal to 1,000 divided by 7. So let's keep this in mind and see what's gonna be our z-value. The z-value is equal to the difference between the sample average, which is 15,000, so 15,000, minus the population mean, which is 16,000, that's what we think it is the average income in the population, divided by the standard error, which is 1,000 divided by 7. So let's work out the math over here. Let's go here below. So we got the z statistic, which is equal to 15,000 minus 16,000. That's minus 1,000 divided by 1,000 over 7. Now if we do some math over here, we know that minus 1,000 divided by 1,000 over 7, it's minus 1,000 multiplied with the inverse, multiplied with 7 over 1,000. We can see that we can cancel out some terms, so the 1,000 and the 1,000 go away, meaning that the z-value is equal to minus 7. Now the z-value is equal to minus 7, but what we're looking for is the p-value. So the p-value means the probability that we're going to have this z-statistic. So if we look in our distribution, the z-distribution, on the z-distribution with the mean of 0, the probability that we have at least a value of minus 7 or less than that is going to be very small. It's not even in the distribution, so it's going to be very, very close to 0. This is almost 0, meaning that the p-value which they claim is not going to be 0.15, it's going to be approximately 0. So the answer is false. Hope this makes sense, and we are done.